Okay. So welcome back for the next session. So in this session, we are going to prepare an NC program for a lathe component. So this is the component. So better to draw this component. So which is having several dimensions like several stepped dimensions like 30, 20, 20 diameter and 14 diameter, and having some radii and having a groove and having some threaded portion over a length of 25 mm. So I need to produce a component, a cylindrical component from the given workpiece by using lathe machine tool, CNC lathe machine tool. So for that, I need to generate an NC code. So just I will explain the step-by-step procedure to generate this particular component directly without any human interface. Just simply if you export the NC code to the CNC machine, so automatically just will generate the component. Finally, it will slice the finalized component from the basic raw material also. So basically just we need to perform operations like, so just first initially just will take somewhat extra size raw material. Suppose if I want to generate a 30 mm diameter workpiece, so generally they will give some extra dimension. So either by using some 35 mm or 32 mm diameter workpiece, by removing 2 mm or 5 mm extra, I can obtain 30 mm diameter, exact 30 mm diameter. Similarly, it is having a length of 60 mm. So generally in lathe operation in lathe machine, we need to hold the workpiece by using check. So directly if I use 60, it is not possible to machine exactly 60 mm because some portion is required. Some portion of the workpiece will go into the check surfaces, check inside the check. So that's why they generally will take more than 60 dimension. So initially the stock material will have larger dimensions compared to the final component. So let us say the stock material is having some 50 mm diameter, the length is 100 mm. Stock raw material. So from that stock material, I need to generate this particular component. So to generate this particular component, I need to perform several operations like turning operation. So turning means reducing the diameter of the workpiece. Suppose let us say it is if the workpiece, if the raw material is having 50 mm diameter, if I want to decrease 30 mm, so I need to suppose let us say up to this we are having the workpiece raw material. So from here to here we need to decrease the diameter. That means we need to remove the excess material from the circumference, periphery of the workpiece. Thereby you can obtain 30 mm diameter. So reducing the diameter of the workpiece is called as turning operation. So generally the turning operation will be performed by using single point cutting tool. So here also we will use single point cutting tool. So to decrease directly some amount of material. So generally if you remove the material in one cut, generally it will generate rough surfaces over the workpiece. If I want to decrease 2 mm diameter, initially I will decrease 1.5 mm thickness. Afterwards, in next turn, I will decrease 0.5 mm. So generally, we will not decrease the diameter in one go. So in different goes, we will remove the material. So that's why first we will perform the rough turning operation. Afterwards, we will perform the finish turning operation. So in rough turning, we will remove maximum amount of material. In finish turning, just we will remove a little amount of material. So always the metal removal rate and the surface finish, both are inversely proportional. If you remove more amount of material, you will get rough surface. If you remove less amount of material, you will get smoother surfaces. So finally, the final component should have smooth surface. So that's why generally the turning operation is also carried out in two steps. First, rough turning. Second step, finish turn to decrease the diameters. So to confine the length. So initially the raw workpiece is having, let us say it is having 100 mm. So to reduce 100 mm length to 60 mm length, which operation we need to perform? Facing operation. Facing operation. So removing the excess material from the end surfaces is called as facing operation. So again, by using a single point cutting tool only, just by altering the orientation of the cutting tool in general lathe machine, just by by swiveling the compound rest, we will keep the tool at certain angle and we will remove the excess material from the end faces. So thereby you can finalize the length. So we need to perform facing operation also to finalize the length. So after obtaining a workpiece of some 30 diameter and suitable length, so what are the other operations we need to perform to get this particular component? Inkem perform cheyali. So at the middle it is having a groove over a length of 5 mm. It is having a small groove. Groove means a narrow slot. Narrow slot. So in a narrow gap, the diameter is decreased. By using single point cutting tool, it is not possible to produce. So we need to use a separate tool called as grooving tool or parting of tool. Both are almost similar. So by using grooving tool, we need to perform grooving operation over a length of 5 mm. So grooving is one operation. Next, over a length of 25. So here they are indicating M20 into 2.5. So metric. So what is this notation? Metric thread having 20 mm diameter, 2.5 mm pitch. So the successive distance between the two adjacent threads is called as pitch. So they are showing by using some code M20 2.5. So from here to here, so it is having a threaded portion. Okay, we need to create thread also. Next, I'm adding one more operation. So exactly at the center, I need to create a small pole, a small horizontal pole exactly at the center line. So drilling operation. Okay, first rough turning, finish turning, grooving. Okay, grooving, threading operation, drilling operation I am including, and it is a large workpiece. After completion of all the operation, I need to trim. I need to cut off this workpiece from the base material. So I need to perform parting of operation also. I need to separate the finalized workpiece from the basic raw material. So somewhere here it will be held inside the check. So just here I need to cut the finalized workpiece from the basic material. So by that, this process will be completed. Okay. So first, just better to note down this diagram, draw this diagram. So just by using this diagram, first I will model the, actually just if you observe about x-axis. So mostly the in lathe machine, most of the objects are symmetric. Mostly we will prepare cylindrical objects. So this object is also, it is symmetric about x-axis. Here xz. In this particular view, just normal xy. So in this particular figure, it is about horizontal line. It is about horizontal axis. It is symmetric. So now, first I need to model this diagram in MasterCAM. So I am starting from right side. So just to get access line, just press F9. Already access lines are showing. Once if you press F9, function key 9, access lines will be appear. So here just I need to use, just if you observe the diagram, so all mostly we're having lines, and at one place it is having one arc, R5 arc. So starting from, so just either you can select line command by using menu bar or directly from here, end point, end to end point. Okay, so just I am starting from origin. So about x-axis here, just if you observe here, xy. So our object is also about symmetric about x-axis. So just I will draw off portion. So anyway, in lathe operation, in lathe machine, always the workpiece will be in rotary motion. So once if you touch the tool at the top, so as the workpiece rotated on the circumference, the material will be removed. So that's why just I will draw only half of the figure. So starting from right side, so 10, So here just you can observe vertical line, horizontal line. So according to the requirement, you can highlight the feature. Now I want a horizontal line up to a length of 25. So here it is indicating length 25. So just press enter. Okay. So 10 mm vertical line, 25 mm horizontal line. Next. Next 14, 7 plus 7, 633. So again, I want vertical line towards downside 3 mm. 3. Next, further, I want horizontal line 5 mm. 5. Okay. Again, towards top 3 mm. Vertical line 3. Again, horizontal line 10 mm. 10. Next, after this, we are having one curvature. So this curvature center point 25 plus 5, 30, 40, 45 at a distance of 45. At a distance of 45. So from this point to that curvature point, second line, it is at a distance of 45. So that's why first I will locate a point. So from X minus 45, Y 0, Z 0. Okay. So I have created a point at a distance of 45 from the origin. Endu create chesinte I need to draw one vertical line. So the vertical line height is 30 mm diameter and 15 mm. 15 mm line I need to draw. So from here, vertical line 15. 1, 5. So in between these 2 points, line, vertical line 15. We need to mark this right mark. Okay. So from this point to this point, I need to draw an arc. So arc is having r by radius 5. So arc, we know only 2 points. So select the proper option. Create arc endpoints. We know only endpoints. Create arc endpoints. So one endpoint is this one, another endpoint is this one. Okay, and here you can observe either you can specify the radius here. You can specify the radius or you can specify the diameter. So here I am specifying the radius 5. Radius 5. So just if you click, so radius 5, arc is generated in between these 2 points. After that, just click OK. So an arc is created. Further, over a length of 15, 30 diameter is there. So again, line towards left side, horizontal line. How much distance? 15. 15. Next again line. Vertical. 15. Towards bottom. So this line is just for concept to draw that particular arc. I have drawn this line. Now I am deleting this line. This point also I am deleting. Okay. So this is the arc of the given component. Okay. So with this, modeling is over. So next, first I need to perform rough turning operation. So to perform rough turning operation, first we need to have a stock material workpiece. We want workpiece and we need to hold the workpiece inside the check. So which machine we are using? Lathe machine. So after using all these sketching tools, I am going towards machine type. So we're having milling machine, lathe machine, wire EDM machine, rotor, design, etc. So I need to select lathe. From machine type, select lathe, select default settings. So I have drawn original dimensions only. According to the figure, I have drawn the figure. According to the given dimensions, I have drawn the figure. Now I need to define the stock, define the jaw, etc. So first just click machine type, select lathe machine. So once if you select the lathe machine, so left side you can observe. So previously all these options are not there. So this particular window is called as operations manager. Operations manager. So if you want, you can press Alt O. It will display. Once again, if you press Alt O, it will disappear. So according to the requirement, you can hide or you can unhide the operations manager by clicking Alt plus O. Now, student. So after selecting the lathe machine, now I need to define the stock, define the workpiece. So just double click over the properties. Okay. Stock setup. You can observe one option is there, stock setup. So click on stock setup. So it will prompt you one more window. So here we are having two options. One is stock, other one is check jaws. So under stock, so left spindle not defined, right spindle not defined. So mostly the lathe machines are of left spindle type. So our lathe machines are also towards left side. We are having check and we are holding the workpiece. So left spindle. So under this stock, select properties. Properties. Okay. Now outer diameter. So actual diameter of the workpiece required is 30 mm. So by default, they are giving 50. So either you can give 40, 50. It must be more than 30. It must be more than 30. So just as it is, I am keeping 50 mm OD. You can give 40 also. Okay. So depending upon the raw material dimension, so just specify the dimension here. So I'm using same 50 default. Length. The component length is 60, but here the raw material workpiece length is 100. Why we need extra length? Because we need to hold the workpiece. Exactly, if you use 60 for holding itself, it will take some length. So it is difficult to perform the operation up to 60 mm length. So on the connect, we need to give some extra length. So here 100. Okay. Next, position along x-axis. So actually, so here towards right extreme. So we need to perform facing operation. So to perform facing operation, we need some extra material towards right side also. So for that one, just I am giving 5 mm extra towards right side. Okay. So just if I give this 5 mm, so the 5 mm will be covered in facing operation. Okay. Next. So after defining the stock dimensions, 50, 100, if you want, you can change it. Instead of 50, you can give 40. Instead of 100, it must be more than the dimensions of the final component. So 50, 100 defaults unchutunnanu. So after that, just click this make from 2 points. This is the final workpiece, final raw material. So from this, make from 2 points. Sure. So this hidden line, dotted line is indicating stock material. Stock material. So actual workpiece is this much only. From this big workpiece, we are generating this 30 into 60 stepped workpiece. Adhamainda? So here the pacing operation 5 mm extra we have given. So this 5 mm is towards right side. Okay. So this entire material will be removed by performing several operations. Okay. Next. First point. So next definition of stock material is over. Next, check jaws. So here also mostly we'll hold the workpiece by using left spindle. Properties. So just select one of the check. Okay. Properties. Make from 2 points. So over the left side, we need to hold. One second. Properties. Make from 2 points. So click on OK. Okay. So this is the workpiece, hidden line. So these are the checks. Check. So the raw material is held between the check. So we need to generate a component of these dimensions. So first we need to define the stock as well as we need to arrange the check. So the procedure is first stock setup. So click on stock setup. So initially the stock is not defined. To define the stock, click on properties. Inside the properties, just mention the outer diameter of the workpiece and length of the workpiece. To perform facing operation towards right side, give some extra length. Otherwise, it will start exactly from the origin. So give some extra length like 5 or 2 mm according to the requirement and click on OK. After this, check jaws, properties. So click the type of check, OD1, OD2, OD3, different checks are there. So most commonly used to hold the outer diameter workpieces is this one, first one only. So select the first one and click on make from 2 points. So just we need to draw from one point to other point. Just if you draw one rectangle, so automatically the check symbol will come. Okay. Okay. Next. So after holding the workpiece, the first step is rough turning operation. So to perform the rough turning operation, I need to create a tool path. First we'll perform facing operation. First facing, next rough turning, next finish turning. So just select tool path, machine type is over, stock setup is over. Next tool path, I need to generate a tool path for facing operation. So tool path, face, click on face. So just click OK. Here, just if you observe, we're having different types of tools. So tool job, number of tools are there. The workpiece is held inside the left check. So I need to use a right side tool, right side rough tool, rough right. So this is the better tool option which is used over the left held workpiece, left check held workpiece. So just click on this, select this tool. So tool is having a 0.8 nose radius, outer diameter, rough right 80 degree. Okay, so select this right rough right tool. So tool number. So actually the tool number means if you observe any CNC machine, it carry many number of cutting tools, some n number. So maybe it is 12, 24. A tool magazine will be there. Over the magazine, it will carry number of tools. So here every tool will have some number. Suppose the same machine tool magazine will hold one single point cutting tool, drill bit, reamer. So many tools are there. So each tool will have some number. So according to the rough right tool, we need to enter this number. So according to the tool number only, in NC code, the same number will be appeared. So here if you write 1, so NC code will call only first number tool. So that's why we should know where exactly our tool is placed over the tool magazine. So accordingly, if it is 1, we will write 1. If it is 12, we will input as 12. Okay, so feed rate. So in case of lathe, it is measured in terms of mm per revolution. The distance, the axial distance of the tool traveled in one revolution of the workpiece. So according to the requirement, we can give 0.25, 0.35, 0.45. So by default, it is showing 0.25. Just I am using the same. Spindle speed, RPM. RPM are CSS, full form? RPM or CSS. Generally, we'll use RPM. So whether it is rotating under 400 RPM, 500 RPM, 600 RPM. So again, this RPM depends on the type of workpiece material, type of operation, type of workpiece material, and type of cutting tool material. Maximum spindle speed. So every machine will have some maximum capacity. So just if you observe our ordinary machine tools, it will run on up to some 1500 or 1200 RPM only. So the CNC machine may be having some 3000, 4000 RPM. So we can specify that one also. Beyond that, it will not run, it will not rotate. So after entering the suitable values, okay, so just I'm using defaults only, mm per revolution, CSS. So just click on OK. So select the tool, specify the tool number, specify the feed rate required, specify the spindle speed. You can use any type of units. Okay, only these two, 1, 2, 3. So these 3 parameters you can change. So other things mostly default. So click on OK. Okay, a tool path created and machining operation is performed. So how to see whether the machining operation is performed? Machining means facing operation is performed or not. So just to check, so just click this verify selected operations. Okay, so it will give you a 3D figure. So just reduce the speed and just click. So some material will be removed from the end surfaces. So thereby the length of the workpiece is decreased. So this operation is called as facing operation. Okay, by using a single point cutting tool, just here instead of showing a bigger cutting tool, just they are indicating one insert. A small piece is insert. It is a cutting tool only. So instead of showing the entire lengthy cutting tool, they are showing one insert. Okay, so facing operation. Okay, so this is the tool path. This line is tool path for facing operation. So just we can hide the tool path also because several operations need to be performed. So if all the lines are appear over the window, it may create confusion. So that's why by using this toggle display on selected operations. So if I click this one, you can unhide that tool path line for facing operation. So facing is over. Okay. Next. Because on the stock material also 5 mm extra material it is removed. So next operation is rough turning operation. So again, just go to tool path, rough turning, rough, select rough. Okay. So here it is asking from which point to which point or under which line we need to remove the material. So select the path. So just select this chain and from here to here. So over this line only, this is the material we need to remove from the workpiece. So select the path. Okay. And click on OK. For every operation, it will ask the tool, type of tool, tool number, and the parameters related to that operation. So here also, so as the workpiece is held into the left side check, so mostly we'll use a rough right tool. In previous operation, we have used rough face right facing tool. So in this operation, we need to use rough right tool. In the use face tool use rough tool use. So actually we need to use face right tool. Rough only facing operation tool we need to use. So here rough right tool. So tool number, it is already fixed. In earlier case we have fixed already. The same tool it is by default it is taking. So feed rate same. Spindle speed if you want you can change. So just I'm using the same options. So these options will change based on the type of workpiece material, type of cutting tool used. Okay, just for demo purpose I am using the default options. Okay, so just click on OK. Okay, so now to observe the 3D machining isometric view. So just click facing operation, turning operation, rough turning operation. Okay, rough turning operation. So just I am hiding the tool path lines. Next, just if you observe further stock, further we need to remove some material. So in finish cut, we can remove that small excess material. So again, same, select tool path, finish cut. Finish cut. Again, we need to select the chain path from here to here. Click on OK. Again, it will prompt. Select the tool. So here we need to select finish right tool. Finish right tool. The tool number according to your tool magazine we need to input. So here by default it is taking 21. So in your machine it may not be at 21st place. So it may be at 10th or 11th according to the fixing of tool. So that particular number you need to input here. So again feed rate, spindle speed, maximum spindle speed. So according to the workpiece, according to the operation, generally compared to rough cut, the finish cuts will be operated under high speeds. Okay, if you perform the operation at a very high speed, generally you will get smoother surfaces. So that's why by default also it is giving 550 CSS. In earlier case, some 225 or 250 CSS. So by default, just I'm taking. So just click OK. So now we got a finished cut. So now just if you observe 3D, facing operation, rough turning operation, finish turning operation. Okay, so finish turning is over. Next, I need to remove material from this narrow groove. So for that one, same tool path, grooving operation. So just click groove. So it is asking, so many options are there. So first point, second 2 points, 3 lines, chain, multiple chains, etc. So I need to remove the material from 2 points. So according to the option, according to the requirement. So I am selecting 2 points. First point, second point. So just similar feature is available. Similar properties are there for our workpiece also. So just I need to select these 2 points. So click OK. Select the first point. Select the second point. Press enter. Okay. Again, so after selecting those 2 points, we need to choose the tool. So which tool I am using? I need to use grooving tool. So grooving tool, we're having several types. So we need to use right tool, grooving right tool. Narrow, medium. So our gap is 5 mm. 5 mm and small, a narrow gap. So I'm using a narrow right grooving tool. Narrow right grooving tool. Feed rate, according to the requirement, you can change the options. So grooving tool number, according to the tool magazine location, we need to input the tool number. According to the type of workpiece material, type of cutting tool material, we need to choose speed, feed, etc. So I'm using the defaults. Just click on OK. A groove is formed. In a narrow space, the material is removed by using grooving tool, grooving operation. So in 3D, just if you want to see symmetric view. So directly you can see only one operation. Suppose if you place the cursor at the beginning, all operations it will show. Suppose if I place the cursor at only the groove. A groove is formed. Think of further. Rough turning, finish turning, over, groove is over. Next, threading and drilling. First, I will show you drilling. So exactly at the center, just I am going to drill a small hole over the workpiece at the end face. So for that, I am using again tool path, drill tool, drill bit, drill. So we are having different tools. So generally, if you want to perform any drilling operation, first we need to use a center drill. Center center drill. So just it will create a very small hole over the workpiece. After that, if you use drill bit, there is a safety concern for the drill bit. So, but here instead of using two times, directly I am using a drill bit of 3 mm diameter here. So tool number, feed, speed feed, we need to input. So just click on OK. What are the 3 parameters we need to input? Tool number according to the tool magazine, according to your machine configuration, feed rate, spindle speed. Click on OK. So I have not selected the point. Parameters. Depth of cut. I have not given the depth of cut. Hole is having some depth of cut. Say some 8 mm is 8 mm. Okay. So 8 mm a hole is formed over the end face. So here you can use different colors also. Change to color. A hole is formed. If you want all, so just place the cursor at the top. A hole is drilled. Further, we are having thread over a length of 25 mm. Same. Tool path, thread. Just select thread option. So again, use right and thread. So according to the requirement, just select any right hand thread. Okay. Thread shape parameters. Start position, end position. And major diameter is the major diameter 20. Minor diameter is 14. 14 14. Thread depth automatically came. They have specified the pitch. Pitch. Here is, if you observe, distance between two successive points, they are showing it as lead. Pitch and so here just specify 2.5 according to the requirement. 2.5 mm per thread. Okay. Start position from where to where? Start position to end position. In between two lines, we want threading operation. So start position. Start ikkada. End position. Select the end position. Ekkada end kavali ikkada. Okay. So minus 25. So directly you can input 0 and minus 25, or else you can select the start position and end position from the screen also. Okay, 0 to 25. Towards left side gravity, minus 25. So all the parameters are given. So after giving all the parameters, if you want, you can change the thread angles also. Different types of threads are there. Metric thread, acme thread, buttress thread. So according to the requirement, just we need to input all the parameters over this window. So after that, click on OK. Okay. In 3D. Symmetric view. So threaded portion. So this is threading operation. So after performing all the operations like turning, grooving, threading, drilling, next finally we need to trim. We need to cut the final component from the raw material. So for that one, we are having one operation called as cutting of operation. So here at this line, at this end, we need to trim, we need to cut off. So again, tool path, cut off. So select cut off. Select the cut off boundary point. Boundary. So select this point. So again, we need to use one tool to perform parting of operation. So grooving tool, parting of tool, both are same. So here, the curvature. Groove right wide, groove right narrow. So just use one of the tool. So give the parameters, tool number, click on OK. So it is asking rapid move violates the tool clearance boundary. So here the workpiece material. So directly it is interacting with the workpiece material. So there may be a collision of tool with the workpiece material. So that's why it is giving warning. So that's why we need to select proper tool for parting off. Tool path, cut off. So we need to use a very narrow tool. Select the boundary point. Narrow. If I use any of these tools, so this portion will interact with the workpiece. If I use only this one, only the straight line portion, there is a less chance of interaction of this left side portion with the remaining workpiece. Is a waste memory. So we'll see this one. Okay. This entire portion will come up to a vertical only. We need to use. Cut off. If the length is more, we can keep any type of tool. So for the selected length, we need to use proper tool. So here, if I take like that, some of the workpiece material will be removed because of collision. So just we need to give some extra length. So in between the check face and the final line of the workpiece, if more gap is available, you can parting off the finalized workpiece from the raw material. So here, because of less gap, the tool is colliding with the workpiece because of gap, shortage of gap. Okay, so we need to change the check location, or else we need to increase the length of the workpiece. అర్థమైందా ఎందుకు collision అవుతుందో అక్కడ ఆ ఫైనల్ వర్క్ పీస్ లైన్ కి చెక్ ఫేస్ కి కొంచెమే గ్యాప్ ఉంది. సో if I introduce parting of tool, so here the gap is not there, so that's why collision is taking place. So if the gap is more, easily you can parting of the finalized workpiece. So irrespective of that error, if you proceed, just observe here. So this edge of the workpiece is removing unnecessarily. It is removing the excess material from the finalized workpiece. So that's why I'm removing this. Okay, so after completion of all the operations, if I want to generate NC code, NC code, so simply just here in the operation manager itself, you can observe G1. One symbol is there, G1. So simply just place the cursor at the top, because we have performed several operations like facing operation, rough facing, finish turning operation, rough turning operation, grooving operation, drilling operation, threading operation. So all the operations are performed over the single workpiece. So place the cursor at the top tool group, starting from first position, first operation. So just simply click this G1 code, G1 symbol. So simply click OK. Tool path group. All operations are selected. G1. Click on OK. So save this NC file, dot NC, desktop. NC lathe. Okay. అది వేరే దాంట్లో ఎందులో వచ్చింది. So just if you observe, directly it is created the NC code. So simply just if you transfer this NC code into the CNC machine, so no need to input every time, no need to remember any codes also. Simply just if you follow some standard procedures for each operation, if you know all the input parameters, easily you can create the codes. So no need to remember what is M06, what is G96, etc., etc. So entirely the software itself, it is developing the NC code. So simply if you run this NC code, so before itself you can see whether any collision is there with the tool or the workpiece. So easily you can simulate and you can see the uh, animation model, and same thing can be implemented into the inside the CNC machine. Okay. So that is the advantage of MasterCAM. So like this, we are having other machines also, not only for lathe machine, not only for CNC lathe. We are having for CNC milling, CNC wire cut, EDM, etc. So by default, it is taken the material as aluminum. We have not mentioned the type of material. Somewhere it will ask inside that window itself, somewhere it